Hey there and welcome back. I think this is going to be a short video, so let me take a sip of water. And let's get cracking. So in this video we're going to implement the IL function, which is the second subfilter in the filter function. And what IL does is it's going to filter the words that kept incorrect letters in their incorrect places. So let me go ahead and open the sample game we played in the beginning. If you take a look at the word arose in the beginning, this S right here is yellow, and that means there's an S in the secret word but not in this position. And so what this tells me is that I can ignore every single word with an S in this position, because we already know it's not there. Otherwise this would have been green. So that's what the IL function does. Or this is the predicate that the IL function is going to use to filter our words. And this is going to be very similar to the CL function, so let's base our work off of that. So as an example, let's take a look at some of the words, and let's try to filter all of the words with a B in there. So let's say that our guess was, I don't know, a base, and our score was, now we don't care, we are only focusing on this column, so let's say that there was a B in there, and let's not care about anything else. So now what we would like our IL function to do is to filter all of these words with a B in the second column, because we know it shouldn't be there. So that's what the IL function will do. So what does the CL function do? It starts by splitting the guess and the score, okay, so that we can work with them separately. And then it does this. So what this does is it finds out the positions where the correct letters are, but now we care about the positions where the incorrect letters are. So it's 1 equals S, and then we filter the guess, or we compress the guess according to that, so that we take only the letters that we know are in incorrect places. Sorry, now I should be using the full name. So the guess is this thing. Let's give it some space to breathe so we can see that there's an assignment hiding in there. So this gives me all of the letters that I need to worry about. And now it does an and.equals to make sure that all of the letters in the words match those. So then we want to filter our words, so let's see. P compress sub. So this is the second column of sub. Alright? So now again we had CL and we had this expression. And over here we have the compression. So now what do we want to do? Do we want to make sure that all of these match up? No, it's quite the opposite. We want to make sure that all of these don't match up. They need to be different. All of them. Let's see if I can give you a more specific example. I'll give it afterwards. So we need to make sure that all of them are different. And after that, we can just compress the words we have. So notice we got rid of all of the words with a B in the second column. And to make sure you understand what this is doing, let's actually change the guess. Let's pretend that the guess was, I don't know, a back, and let's pretend that the score was 0, 1, 0, 1, 0. So now we have a B was scored with 1 and the C here was scored with 1. So we need to make sure that the second column doesn't have B's. Right, this is not what I wanted. I wanted to make this more strict. So instead, let's go ahead with the E over there. So let's pretend that the guess was something with an E here. So this was the guess, but the score was this thing. Nonetheless. Alright, so what I was trying to say is that the B can't be in the second column. So here we need to get rid of all of the B's. So all of these words need to go. And the E cannot show up in the second to last column. So this column cannot contain E's. And that means this also goes. So if we rerun this expression, we see that one more word is missing, this one. And this right here this is taking those corresponding columns and comparing them with BE. And in particular, it's doing a direct comparison, making sure or trying to check if they're different. And then it tries to see if all of them are different. And if they're not, we drop them. Or if they are, if all of them are different, we keep them. So we keep this one because it's different from this one, and we keep this one because it's different from this one. And that's essentially IL. So like I said, it's very, very similar to CL. So let's edit IL. And it's exactly the same thing, except this is a different or not equals, and this is a 1. 1 equals S. So now if we do a guess score of, or then IL and then our words, we see that these two words go out. And if we try all of the words here, we get a bunch of things. I shouldn't have done this. But yeah, so notice that no E shows up in here and no B shows up in here. And we can do this for like the whole column. So this was the function IL. So our filter function has 3 subfilters and 2 of them are completed. So we've done CL and we've done IL. We are only missing WI. And WI I think is the one that is more trouble. So remember, WI is supposed to filter all of the words. It's the final filter, it's just the things that we are left with checking, and it makes sure that the overlap between the current guess and the candidate word is exactly what it needs to be. So in other words, it's going to make sure that the candidate word does not have an overlap with this A and this R, because we already know that the secret word doesn't have A's, nor does it have R's. And it checks that the S exists somewhere in that word. So that's what WI will do. And we'll tackle it in the next video. So go have a think, try to implement it, and I'll see you soon.